Okay, in this lecture we're going to be talking about series and parallel circuits in the HVAC industry. So just as an introduction to this, so far we've looked at circuits that have one path for electricity to go as well as a single switching device. As you continue to work in the HVAC industry, more and more of the circuits will become much more complex. Therefore, we have to understand two ways that circuits are originally designed. But having said that, there's more than two ways circuits are put together, but we need to start at the basics. A series circuit exists when the flow of electrons, or current, has to pass through a series of components. Series means in one line. Switches that control loads are wired in series with these loads. So an example of a series circuit is line and neutrals there. So in order for the current to pass through this circuit, we got to first go through line. Okay, then we have to come down through the service switch. Then we come through switch 1, switch 2, and then through B1, B2, and back to neutral. There's no way for current, the way it is wired, to jump over B2 or pass through switch 1 and then get to the loads if switch 2 is still open. So there's only a single path for current to flow. So in that series circuit, switch 1 is wired in series with switch 2, which is in series with B1 and B2. If any of these components are open, okay, the remainder of the circuit fails. Okay, if one of the bulbs burns out, the remainder of the circuit won't work either. Loads in series split the source voltage based on their resistance. So if we go back to this screen here, okay, neither B1 or B2 is going to get the full source voltage. It's going to be split between the two loads. The amperage in a series circuit is the same throughout the entire circuit. Again, if you have one path for electrons to flow, the speed of those electrons, which is controlled by the loads and the source voltage, okay, there's only one path, so they can only flow at one speed. The total resistance is the sum of all the individual components. So if bulb 1 has 10 ohms resistance and bulb 2 has 20 ohms of resistance, the total resistance of the circuit is going to be 30 ohms. Where you're going to see series circuit, it's very rare to see series circuits with loads in series. Okay, the only time you really see that is with electric heat. It's frequent to see switches in series. Both switches must be closed to provide a path for electricity. In a series circuit, any open will cause the entire circuit not to work. So when you're troubleshooting a series circuit, you have to start by making sure all the switches you can close are closed. Some of them you can't and you won't be able to see, but in this case, we are going to make sure our service switch, switch 1, switch 2 are closed. Now, the reality is B1 and B2 should be operational at this point. So we start off by checking our voltage across the source. We have to, right there, if we do not have 120 volts at line and neutral, you know there's a problem with the circuit. Then you start hopscotching through the circuit. Check the voltage across the first switch. Should have 0 volts because voltage across a closed switch is 0. Okay, then we want to continue going on to the line and load side of each switch. Okay, and we need to make sure that we continue to have 0 volts all the way down to our loads. Then we go across our first load and we get 60 volts. Okay, well, it's not 120 volts because we have two loads in series here that are splitting the voltage. So 60 volts is valid. Go over to the right side. Okay, and then across both bulbs, because it adds up to the total source voltage, we'll have 120 volts. So we've gone all the way through here, and across every switch we got 0. Across the first bulb we got 60. Across the second bulb then we got 120, which is our total voltage. This circuit is good. When troubleshooting a series circuit, if you get source voltage across any switching device, that switch is open. Now, source is not always 120. It could be 24, it could be 240, it could be 480. When troubleshooting a series circuit, if you get source voltage across a load and the load is not operating, the load is bad. So again, careful what I said there. When you get source voltage across a load and the load is not operating, the voltage is bad. So again, if you have an open in a load, like a winding's broken in a motor or something like that, it acts as an open switch. It's going to give source voltage. If you have more than one load in a series circuit, and if the load is operational, you're going to get less than source voltage. Parallel circuits are the most common circuit in the industry for loads. Series circuit we use is for switching and safety. Parallel circuits are for loads. They are circuits that do the most work, and that's because all loads in parallel receive full source voltage. There's none of this voltage splitting stuff going on anymore. Everything receives full source voltage. So parallel circuits exist when a circuit has more than one load, but none of the loads receive voltage from another load. If one load burns out or goes bad, the remaining loads will continue to operate. All the loads get full source voltage. The total amperage of the circuit is a sum of all amperages in the load. Think about a house or a building. Every light switch, or every light bulb in the building gets full source voltage. So let's say in your house, every light bulb gets 120 volts. You might have more than one on at a time, and if one burns out, the others still run. That's because your house is wired in parallel. Back at the breaker panel, everything adds up to the amperage coming into the building, but everything is still getting 120 or 240 volts depending on what it is. So this is an example of a parallel circuit. You have one switch controlling two loads in parallel. So each one of these loads, because it's connected directly to line 1 and neutral, this is still a direct line 1 connection through here. You're getting 120 here, you're getting 120 on B2. The amperage of these adds up to our total amperage. So if B1 is using 6 amps, B2 is using 4 amps, our amperage for this circuit is 10 amps. Here's two loads in parallel, each controlled by a switch. This would be like light switches in a room. Room 1 has a switch for the ceiling light. Room 2 has a switch for the ceiling light. They're independent of each other. One burns out, the other will still run. The same procedure as a series circuit applies for troubleshooting a parallel circuit. Use your meter. Close all switches. First of all, you should be able to have a visual and see which load is operational. But let's say you just cannot see which load is operational. Take your meter across L1, L2. In this case, we're saying 240 volts. We have source voltage. So we know our circuit is getting power. Go between line 1 and the first branch. By the way, each one of these are considered branches of a parallel circuit, or rungs of a ladder. You'll hear it referred to in both ways. This is a ladder diagram. Then go to the left side of switch 1. Right side of switch 1, we should have 0 volts because there's no break in the power from L1 to this point in the circuit. 0 volts up to the bulb. Cross the bulb, or B1, I'm going to get 240 volts because voltage across a load is full source voltage in a parallel circuit. You do the same with the other branch, and as long as the loads are operational, you basically have good loads. When troubleshooting a parallel circuit, if you get source voltage across any switching device, it means it's open because voltage across an open switch is source. When you're troubleshooting a parallel circuit, if you get source voltage across any load and that load is not operating, the load is bad. Again, voltage across a not operating load is still source. Voltage across an operating load is source. The difference is one is working and one is not. As you troubleshoot these circuits, always start at the source and work your way from there. If you get a voltage across a switch, that switch is open, or it could be bad. If you get voltage at a load, the load is not working and has failed, replace it. So that's a little bit about series and parallel circuits. You'll use these and you'll expand on that all the way through. But again, key concepts. Series splits voltage across loads. Series circuits is used mainly in safety devices and switching. Parallel circuits are the workhorse of the industry. Parallel circuits, every load gets source and the amperage adds up to the total amperage of the circuit.